Hi, and welcome to this video from the straight line topic of higher maths, looking at collinearity. From this video, we want to be able to compare gradients to test for collinearity and be able to state and justify your findings with regards to that, which is something that you'll need to be really thorough with to ensure you get all the marks. Now, what we're going to look at first is what happens when we have two different lines in a plane. Okay, so we're just dealing with two different lines. Now, when you have two lines, there's three different possibilities. Either, and this is by far the most common, you'll have two lines that meet in one place like that. Okay, so there you have ABC and ABC, AB just intersects BC. And in that situation, the gradient of AB has to be different to the gradient of BC. Okay, otherwise they don't meet at an angle like that. Okay, another option we have is if you have two lines that are parallel. Okay, if you have two lines that are parallel there, then there AB and CD, your gradients have to be equal and the lines will never meet. Okay, so lines never meet, okay, as the nature for parallel lines. Your third option, which is what really we're going to look at today, is if you have two parallel lines again, but actually they meet at one point. Sorry, I'm just being too careful with that. If you have two parallel lines, but they meet at one point, then you're going to have A, B, C. Again, your gradients are going to be the same, but this time there's a point in common. That B has to be part of both lines, so B would be a common point. Okay, and that there, very neatly written that one. That there is what we mean by 3 points being collinear. Okay, so all 3 points there essentially lie on the same straight line. Okay, and if we want to prove that 3 points are collinear, then that bubble there is what we need to do. We need to show that the gradients are the same the whole way along the line. Otherwise, we'd be looking at something like this, and obviously they'll go at a point in common. So that B will be the whole way across the line. That's how we're going to prove collinearity. There's a short note for you that you can copy down, just summarising that. Okay, give it a wee pause and copy, and then we're going to look at an example. Okay, so what we want to do here is we want to prove that the points P, Q, and R all lie on the same straight line. Okay, so we want to prove that P, Q, and R are all in the same straight line. Now we do that by proving that the gradients are the same the whole way across. So let's look at that first. Let's look at M of PQ. Okay, which is going to be 0 subtract negative 2, and then negative 1 subtract negative 3. That's going to be 2 over 2, so it's just going to be 1. Okay, then it doesn't really matter what combination you pick. I'm going to pick PR. So PR is going to be 4 subtract negative 2 over 3 subtract negative 3, which is 6 over 6, which again is 1. Now, because the gradient is the same between all 3 points, we're either looking from back here, either at this situation or this situation. But because we know we've used P twice here, we've used a point in common, so they have to be on the same straight line. So these 3 points have to be collinear. Okay, now we've done the maths, now we need to do our justification. Okay, so what you want to say is exactly what you've done. So we've said that MPQ is equal to MPR. Therefore, we know that PQ is parallel to PR. Okay, so that's us saying, right, we know they're parallel, but also because P is a point of common, and since P is a point in common, P, Q, and R are collinear. Okay, and that's your full explanation. There's 4 parts to it. First, you say the gradients are equal. Okay, that's what I found out. That tells me that those two things are parallel, and because that P is in both, they have to be collinear. That's your full explanation there. Okay, and that's what collinearity, proven collinearity is always going to be. Same gradients, point in common, therefore they're collinear. Okay, example 2, a little bit trickier here. The points A, B, C are collinear. Okay, so this time we've been told that they're already collinear. We're not proving that, and we need to find the value of K. Okay, take a wee pause, see if you can figure this one out yourself. Okay, so what we're looking at really here is, because they're collinear, we know the gradient is constant the whole way across that line. If it wasn't, we'd be looking at a kink. Okay, so we know the gradient has to be constant. Because we know A and C, we know both those points in full, we can figure out what that gradient is. So 7 subtract -1 over 5 subtract 1, that's going to be 8 over 4, which is just 2. So we know the gradient the whole way across that line has to be 2. Now we can say, well, actually, if I know the answer to the gradient has got to be 2, I can calculate between A and B. So the gradient between A and B is going to be K subtract -1 or K plus 1 over -1 subtract 1, which is -2. But I know the answer has to be 2. And in there, I have an equation. K plus 1 divided by -2 has to be 2. If we multiply both sides by -2, then K plus 1 has to be -4, and then subtract 1 from both sides, K is -5. Okay, that's a kind of more complicated thing, but just using what we've done with collinearity to work backwards and find an unknown value from a coordinate. If you need any more help, ask your teacher, do some work for yourself. Perfect, thank you.